For this first example, we want to graph the line 4y plus 3x plus 6 equals 0. Now to graph a line, we pick any 2 points on the line by letting x or y equal any number we like, and then we find the corresponding y or x value using the equation of the line. Now usually the values that we pick for x or y are x equals 0 and y equals 0. Maybe it's because they're just a bit more convenient. If we put 0 into the equation breaks down more easily. So by letting x equals 0 and y equals 0 in the equation of the line, what we will actually be getting is the x and y intercepts of the line. That means the points where the line cuts the x and y axes. So I will let x equals 0 in the equation, but we can let x equal anything we like. We could let x equal minus 1 or plus 100.5, doesn't matter. If we put 0 in, however, the equation will break down more easily. So we just write out the equation replacing x with 0 because we're letting x equal 0. So let's see what we get for y if x is 0. Well, 0 times any number is 0, so this bit goes out, so we get 4y plus 6 equals 0. Solving this equation for y, we get y equals minus 6 over 4. Well, minus 6 over 4 is the same as minus 3 over 2, or minus 1.5. So when x is 0, y must be minus 1.5. So we have the point with coordinates 0, minus 1.5. This point satisfies the equation. If we were to plug this point into the equation, it would satisfy it. In other words, we would get 0 on the right hand side. That means that this point is on the line. So let's look at this point. X is 0, y is minus 1.5. It's actually this point here. This point is called the Y-intercept of the line. It's where the line intercepts the y-axis. Intercepts or crosses the y-axis. To get a second point, we could let y equal anything we like, or we could let x equal anything, but normally what we do is we get the x-intercept for the line. So to get the x-intercept, we let y equal 0. Again, we're not tied to this value. We could let y or x equal anything we like, but this happens to be convenient. So we write down the equation of the line and we replace y with 0. And we solve this equation for x, because 4 times 0 is 0, that goes out. You see, if we put some other number in for y, suppose we put 1 in for y, we'd have 4 times 1, which would mean a little bit more algebra to do. But anyway, if we put 0 in, we just get 0. So solving this, we get 3x plus 6 equals 0. X equals minus 6 divided by plus 3, which is minus 2. So when x is minus 2, y is 0. So minus 2, 0 actually satisfies this equation. That means that minus 2, 0 is a point on the line. So let's plot that point. Minus 2, 0 is the x-intercept of the line. That is the point where the line intercepts or cuts the x-axis. So we can then draw a line between these 2 points. So 2 points is enough to draw a line. Any 2 points will do. So here is the line with equation 4y plus 3x plus 6 equals 0. Now, as I said a few times before, we can use any values of x we like. Let's just get a point by letting x equal, say, 2. So we write down the equation, replacing x with 2. So if we solve this for y, we get 4y plus 6 plus 6, or 4y plus 12 equals 0. And y equals minus 12 divided by plus 4 is minus 3. So that means that the point with coordinates 2, minus 3 satisfies this equation. In other words, if we plug 2 in for x and minus 3 in for y and work out all of the left hand side, we should get 0. So 2 minus 3 is a point on the line, and you can see that point over here. Here's the point 2 minus 3. So we could have got this point. Similarly, we could have let y equal anything we like. Let's suppose we let y equal 2. No, let's say 3. We write down the equation of the line, replacing y with 3. we solve this equation for x. 4 3s are 12, 12 and 6 is 18, so we get 3x plus 18 equals 0. X equals minus 18 over plus 3, that's minus 6. So you see we get a point with coordinates minus 6, comma 3. This is a point on the line. And we can see here's minus 6, here's plus 3. The slope-intercept form of the equation of a line is y equals mx plus c, where m is the slope and c is the y-intercept of the line. I'll just take an example to explain this. In previous videos, we looked at the line 4y plus 3x plus 6 equals 0. The slope of it is minus 3/4, and the y-intercept, that is where the line crosses the y-axis, has coordinates 0, minus 1.5. We saw that in a previous video. So we want to write this line in slope-intercept form. That means we want to make y the subject of this equation. So we want to get y on its own, so we start by isolating the y term. So we isolate 4y and bring everything else across. The next step is to get y, so we have to divide everything by plus 4. So we divide this term by plus 4. Minus 3 divided by plus 4 is minus 3/4. So we get minus 3x over 4, or minus 3/4 x. Then we have minus 6 divided by plus 4. That can be simplified to minus 1.5. Or if you like, minus 3/2. So now we have it in y-intercept form. So when y is made the subject of the equation, the coefficient of x is the slope, m, and the constant term, this term here, it's just a number, it doesn't involve x, is called c. It's the y-intercept, minus 3/2, or minus 1.5, this point here. So if you have the equation of the line, you can get the slope by writing the line in this form. You can also get the y-intercept, but the slope is usually what's needed in questions. Slope is usually more important than the y-intercept. Anyway, as an aside, let's ask, why does writing a line in this form give us the slope and the y-intercept? First of all, let's consider the y-intercept. Well, our equation in y-intercept form is y equals minus 3/4 x minus 3 over 2. To get the y-intercept, we let x equal 0, because any point on the y-axis has x equal to 0. So if we plug 0 in for x here, we'll get the y-intercept. We'll get where the line cuts the y-axis. So we have minus 3/4 times 0 minus 3/2. But any number times 0 is 0. So we see we just get y equals minus 3/2. So we get a point with coordinates 0, minus 3/2. So now you see why this number must be the y-intercept. By letting x equals 0, this term disappears. So we're left with y equals this number. So when x is 0, y is minus 3/2. To see why the coefficient of x gives us the slope of a line when the line is written in y-intercept form, we look at the value of y when x equals 0. Well, we know that that's the y-intercept, minus 3/2 or minus 1.5. Then we look at the value of y when x is 1. So let me show you the picture. Now, all of this is just an aside. You can really just ignore this. But for anyone interested, when x is 0, y is minus 3/2. When x is 1, then we can get this value here. In a previous video, I explained that if we pick any point on a line and increase x by 1, so we just go 1 unit to the right from the point, then the distance that we go up or down to the line is the slope of the line. Now in this situation, when we increase x by 1 from this point here, we have to go down to meet the line. So that means the slope will be negative. Now the distance that we have to go down is this distance here. The distance at x equals 0, the y value of this point is minus 3/2. But you see we have to go down this further distance. by basically letting x equals 1. We have this extra distance to go down. We get down to minus 9 quarters actually, the value this way. But that's not what's important. What's important is the distance that we have to travel, which is 3 quarters. So that's one way to get the slope of a line. Pick any point, increase x by 1, and then see how far up or down we have to go. And you can see that when the line is in this form here, when x is 0, we just get the intercept. But when x is 1, we have this extra distance, and that's the slope. It happens to be minus 3 quarters here because we have to go down a distance of 3 quarters. The slope is negative. So that's why the coefficient of x is negative. All of what I said for the last few minutes is an aside. Most people can ignore it. The main thing is to know how to get a line in this form and then to read off the slope. So it's just an exercise in basic algebra.